Hello everyone, this is your instructor Sir Adam. Hope you are doing well. Today's topic is geometric properties of circle. In this video basically we are going to be looking at symmetric properties of circle. So the first property is related to the deals with a line passing through the center of the circle to a chord. By the way, what is the chord? A chord is any line that touches a circle at 2 points. It does not pass through the center of a circle. If it was passing through the center of a circle, then that would become diameter. So this is a chord that passes through the circle at 2 points, circumference of a circle at 2 points. So the property says that if a line L, there's a line that passes through the center of the circle, okay, through the center of a circle in such a way that that line is perpendicular to the chord, then the property says that that line is going to bisect the chord. Okay, it's going to divide the chord into two parts. So if I draw a perpendicular line from the center of a circle to the chord, it is going to bisect the chord. So for example, if AB was, let's say, 7 centimeter, and this is going to be the midpoint, okay, let's say N. So AN, the distance of AN is going to be 3.5 and NB is going to be 3.5 centimeter. Okay, similarly if you have a chord PQ and you drop a perpendicular line, so it is going to bisect the chord into two parts. Okay, so OP is the radius as well, this is your perpendicular line, okay, and this becomes your right angle triangle. Let's look an applet to further understand this. So if I draw a circle center O and A, B are the points on the circumference of a circle, if you draw a perpendicular bisector, these are the construction steps. If you draw a perpendicular bisector, what you notice is that the perpendicular bisector is a line that is going to pass through the midpoint of AB, and it's also going to be perpendicular, and it is going to pass through the center of a circle. Okay, coming back to the property, the diagram shows, let's do a question now. The diagram shows a circle center O. So AB is a chord of length given to you as 12 centimeter, and they have told you that M is the midpoint of AB and OM is 4.5. So this length is basically 4.5. OA is the radius of the circle, as you can notice over here. And now try to recall the property. The property says that if a line passes through the center of a circle, okay, perpendicularly to the point M, and M is the midpoint, so that means that this line is perpendicular. So this is a right angle triangle. The value of AM is going to be half of the value of AB because the chord is going to be bisected. So AB is going to be 6 centimeter. If this is 6 centimeter and OM is 4.5, then to calculate the radius of the circle, which is represented by OA, you can just use Pythagoras theorem, okay, and that's going to be 6 square plus 4.5 square root. That is simple Pythagoras theorem. So if you calculate this, you are going to get, that is 7.5 centimeter. So that was the first property. Okay, the second property is that equal chords of a circle are going to be equidistant from the center of a circle, which simply means that if you know that the two chords AB and CD in a circle are equal in length, then the property says that the distance from the center must also be equal in length. So for example, if AB and CD are equal in length, let's say 7 centimeter. So if you're told, if you know that let's say OM, the distance of AB chord from the center of a circle is 3 centimeter, then the distance of CD chord should also be same 3 centimeter. That is what the second property is. Or you can also say that if you know that there are two chords having equal length from the center of a circle, then definitely the two chords must be equal in length. So AB should be equal to CD length. Okay, let's look at the applet to further understand this. If I try moving, okay, that was one example. If I say that AB is, let's say, 8 centimeter, and I try to adjust the chord CD to 8 centimeter, okay, so when AB is going to be, CD is going to be 8 centimeter as well, you can notice that the distance OM and ON is also equal, and that is going to be the case every time. The distance of equal chords from the center of a circle must be same, must be equal as well. Let's look at a question over here. So a diagram shows a circle center O. AB and DE are the chords of a circle. M is the midpoint of AB. M is the midpoint of AB and N is the midpoint of DE. First of all, if they are the midpoint, if it is a midpoint, then this line OM should be perpendicular. Okay. If AB and DE are of the same length and OM is 5 centimeter, if this distance is 5 centimeter and the chords were equal, then you need to recall this property that says that if the two chords are of equal length, then the distance from the center must also be equal. So OM should be equal to ON, that is 5 centimeter. This distance and this distance will also be equal. The next property is related to the tangent of a circle. So a tangent line, so if there is an external point P and you draw a tangent line from that external point and it touches the circle at one point. So a quick recap, what is a tangent line? A tangent line is a line that touches the circle at one point. So that point, let's say, is X. OQ is your radius of the circle. PX is a tangent line. The property says that the tangent and the radius are going to be perpendicular, meaning this angle is going to be 90 degree, hence making OXP the right angle triangle. So all the properties of a right angle triangle are going to be applicable. Pythagoras theorem or trigonometric ratios, all that are applicable in a right angle triangle will help you solve for the missing values. So you need to remember this property that if a tangent at a point of contact is perpendicular to the circle of a to the radius of the circle. Okay, the radius and the tangent line will always be perpendicular. Now, if I extend this property further, from a single point you can draw two tangent lines, right? So I can see that the tangent line are going to touch the circle at two different points. Let me call this point M and this point as N. Now the property says that if you draw tangent from an external point to a circle, those tangents are going to be equal in length. So over here PM is going to be equal to PN length. Okay, PM, the length of PM and the PN, which are the tangent line, are going to be equal because they are tangents from an same external point. Okay, now would you also agree that OM and ON are going to be equal because they represent the radius of the circle? And OP is basically the common length. OP represents the common length. And if I recall property number 3, that says that the tangent and the radius are 90 degree to each other. So you are getting two right angle triangles over here. Okay. Now the property also says that the line, if you are going to draw the line from an external point to the center of a circle, what happens is that the angles are bisected. So whatever this angle was, it is going to be bisected into two equal parts. Whatever this angle was, this is going to be bisected as well. For example, if this angle, let's say, was 26, okay, so this angle is going to be 13 and this angle is going to be 13. Alright, so if I want to calculate this angle, it's going to be 90 minus 13, that is 77. This angle is also going to be 77. Also you can notice that triangle PMO will be congruent to triangle PNO. Okay, because we have a right angle over here. This side and this side is equal in length and this is a common length. So as per RHS property, the two triangles are going to be congruent to each other. Alright, so that was your property number 3 and 4. Okay, so let's look at this. If I draw a tangent to a circle, so in this diagram APB represents a tangent and OT represents the radius. You can see that the angle between them is 90 degree. If you draw two tangents from an external point A, let's say, the two tangents two tangent line AE and AF are going to be equal in length. Okay, let's look at a question now. So O is the center of a circle. O is the center of a circle. DA, this line DA is tangent to the circle at point A, and DCB is a tangent line to the circle at point C. AOB is a straight line. Angle COB is 50 degrees. So this angle is given to us as 50 degree. We need to calculate angle CBO. CBO is this angle. Now you need to recall the property that says that the radius and the tangent are 90 degree to each other. They are perpendicular. So if that angle OCB is 90 degree, if angle OCB is 90 degree, then angle CBO must be equal to 180 minus the sum of 50 plus 90. Okay, so if you do the maths, the answer is going to be 40 degree. So this angle comes out to be 40 degree. Okay, the next part says find angle DOC. Now DOC is this angle. If you connect point D and O, that is a line from the external point. That is a line from an external point to the center of a circle. Remember, DA and DC are going to be equal in length. CO and OC are going to be equal in length because they are the radius of the circle. So if I know that COB is 50 degree, then COA is going to be 180 minus 50, that is 130 degree. And why is that so? Because AOB is a straight line. Angle in a straight line are supplementary. The sum is going to be equal to 180. So if this angle is 50, this angle is going to be 130. Now if you know that this angle COA is 130, then if you recall property number 4, that says that if you pass a line through the external point to the center of a circle, it is going to bisect the angle. So if this angle was 130, the angle DOC is going to be half of 130, that is 65. So angle DOC is going to be half of 130, that is 65 degrees. I hope these properties are clear to you now. I'll see you in the next video on angle properties of circle. Thank you.